So we're going to do 13.5, and the focus on this is to factor without using a table method or doing any work or much difficult work, two types of polynomials. They're called perfect squares and difference of squares. So let's bring up our guide. So here's pretty much what we're going to be using is this. This is actually, it's definitely worth doing. It can make factorizations much faster, and when you're taking tests, sometimes speed is essential. And they occur so many times, it's nice to know these formulas. I've had these formulas memorized ever since high school. So here's you don't have to, this is the mathematical fact we're going to use. And the thing you need to memorize is this formula right here at the very bottom. So let W and V be two polynomials. They could be entire polynomials. Of course, polynomials can be represented by a single constant term or a single variable term. So that's the reminder. They can be single terms. Those terms could be constants or variables. They could be real numbers, but we're mostly going to focus on integers and integer coefficients. So the following is true, and it's easy to prove these just algebraically. W squared plus 2wv plus v squared is equal to, in parentheses, w plus v squared. And w squared minus 2wv plus v squared is equal to, in parentheses, w minus v squared. So what's going to happen is we're going to be given something like this. Now w is not going to be w and v is not going to be v. They're going to be polynomials or polynomial terms, or perhaps just integers. But we have to match what we're given with these. And once we identify what we're given as my w and my v, then we can check that the first term is really w squared, and then the last term is really v squared, and that the middle term is 2 times wv. And if all of those check, depending on the sign, this sign right here, in the original, whether it has a plus right there or a minus right there, then we can go on to literally just write out the factorization. So let's do this in practice. It's really not difficult, so I don't want to make it difficult. So our first one is 1a. And so we're given nothing, hardly ever. Actually, I chose w and v because we're hardly ever given a polynomial in those two variables. Your book probably uses a and b, but then it gives you a polynomial in those variables, and that can be confusing. So the first thing we want to do is look at the first term, which is the largest degree term, because these are going to be written in order of descending degree. So let's look at my first term, and clearly my w is equal to my, not v, but x. In other words, x squared is equal to x in parentheses squared. And then I look at my last term, and this is usually where the work is. What times itself gives me 25? If any of you know anything about square roots, you realize that is 5 squared. There's no reason to put that in parentheses, but you can if you want, if you're pattern matching. So let me give me a little bit more. I wrote too cramped. I have more room than that. So let's go back. So my w is going to be identified with my largest, my first term, what that is squared. So it's going to be identified with my x. And my v is going to be identified as my 5. Because remember, I'm looking for w squared plus 2wv plus 25 squared. So x squared plus 2x, I don't know what my v is yet, But when I discovered that 25 is 5 squared, then v becomes 5. Well, I don't know if that was helpful or not. Maybe I'm confusing because I immediately identified my 5 with the v value. But that's okay. Just ignore this over here if it's confusing, and just stop right here. So the only thing we want to do is, this is what I'm given, and I want to break it down into x squared plus 10x plus 5 squared, so that my first and my last terms are some polynomial or integer squared. In this case, w would be equal to x, and my 5 would be equal to my v. So the next thing I want to check is, okay, what is the value of my 2wv? Well, 2 times wv. So notice I'm going with the information I found. So w is x, v would be 5. So 2 times w times v, or sometimes we want to do 2 times v times w, because we always want to multiply the real numbers first, and they're the same because we're just multiplying, is equal to 2 times 5 times x. Well, that's equal to 10x. So we look up at our original, and that's exactly what we have in the middle. So first criteria, second criteria, I'm now ready to say this is either w plus v squared or w minus v squared. And we make the choice here by just looking at our original polynomial. And I notice that that is a plus right there. So I'm going to choose this. So my factorization is going to be w plus v squared. And that is equal to, and now is where we do the replacement, my w is equal to x, my v is equal to 5. So I just discovered that x squared plus 10x plus 25 can be factored as x plus 5 squared. And just remember, x plus 5 squared is x plus 5 times x plus 5. So basically, I was given this, factor it. And we could go over here and do this whole method. It would still work. You could put x squared here, 25 here, and 10x here, and you would automatically put x and x there. Then you would learn that you have to have 5 and 5 there, and 5x plus 5x gives you 10x, and you do the factorization, and you get x plus 5 times x plus 5, and that's equal to x plus 5 squared. That method's always available to you, but it's so much easier and nicer in certain circumstances just to be able to look at that and say, oh, that's a perfect square trinomial, and the first term is x, and the second term is y, and it's going to be the second term is 5, and it's going to be x plus 5 squared. So we're just going to do a few of these. Actually, we're going to do as many as we were given to do in the worksheets. So this is number 1b. So 4a squared minus 6ab. I'm going to present this just a little bit differently. So I want to know, do there exist a w? So notice this is a negative here. Can I find a w and a v such that this is equal to w minus v squared? That's our question mark. And if I know that I can find my w and my v, I just write my W there and my V there and I'm done. So the first thing we do is I look at my first term and this has to be something squared. Well, the square root of 4 is 2 and the square root of a squared is a. So 4a squared is 2a squared. What about 9b squared? Well, the square root of 9 is 3, and the square root of b squared is b minus 6ab. So now I want to see if I let my 2a be my w squared and my 3b be my v squared. That means w is equal to 2a and v is equal to 3b. So now I have to check. Now, if I could not write my first term, my term of my highest degree, is some polynomial squared, and if I could not write my last term as some polynomial squared, then I'm done. This is not going to work. The answer to my question is no. But I could. The first term is 2a squared. The last one is 3b. Sorry, I didn't write a square there. I need to write my square there. 3b squared. So I'm almost good to go. The next thing I have to check is, what about 2wv? And since I'm having a negative here, I can do minus 2wv, or you might want to do minus 2vw. Well, that's equal to minus 2 times 2a times 3b. And the result has to be minus 6ab. Well, this is minus 2 times 2 is minus 4 times 3 is minus 12ab. But minus 12ab is not what I have here, so this is not equal to w minus b squared, which would be, in this case, 2a minus 3b squared. So it failed. We did not have a factorization, or the factorization that we had hoped to find. So let's look at the next one. Again, don't make this too complicated. (144) x squared minus 24x plus 1. Getting a weird delay. Anyway. So the first thing I want to do is, can I write my first term as a perfect square? Well, the square root of 144 is 12. And the square root of x squared is x. So that's 12x squared minus 24x. What about my last term? This always gets a lot of students, but 1 is a perfect square. The square root of 1 is 1, so that's 1 squared. So my w is equal to 12x, and my v is equal to 1. So I have to check, since the middle term is minus, what is minus 2wv? And if it's not minus 24x, then I can't factor it. So basically, what I want to know, what I'm checking to see, does this have a factorization in the form of w minus v squared? That's the question I am asking. So, well, I found a w and I found a v. So now all I have to do is discover if minus 2wv is minus 24x. Well, minus 2 times 12x times v, which is 1, is equal to minus 24x. And that's what I have up here. So that means w minus v squared is equal to, my W is 12x, and my V is 1. So I just learned that this polynomial is equal to 12x minus 1 squared. So let me write that a little bit better, because my W is 12x, not just 12. 12x minus 1 squared. Okay, so let's do some more of these. I'm getting a weird lag. I hope it doesn't get worse. So 2a. So I have x squared plus 4x plus 4. So I want to know if I can find a w and a v such this is equal to w plus v squared. Why plus? Because that sign right there is plus. So if I let w equal x, I don't want to put a w there. If I let w equal to x, the first term is x squared. And if I let v equal to 2, the last term is 2 squared. So w is equal to x, v is equal to 2. And you can if you can see this without using this little formula, you're fine. You don't have to introduce new variables, but I like to do pattern matching, and that's what we're trying to do, is pretty much pattern match. So that's okay. My first criteria is I found a candidate for w and a candidate to v. So since my sign here is plus, I want to check to see the value of 2wv or 2vw. Well, that's 2. My constant term is 2, and my other term is x. So that's equal to 4x. Oh, well, that's what I have. So that means this is equal to w plus v squared, where w is equal to x, and my v is equal to 2. So I was just able to factor that polynomial without doing any table. 2b. There's some set of parameters over here that I discovered at one point. Smooth, freehand. Nope, I don't see. I thought one may have had a pause because I'm getting a little bit of a annoying delay. And I don't know what it is. Normally I would just restart my computer, but of course I can't restart my computer because I'm doing a video. And I want to know, is this going to be, since that's a negative here, can I find a v and a w such that this is equal to w minus v squared? So let's see. Well, x squared is equal to x squared. I just put it in parentheses. And the square root of 49 is 7, so 49 is 7 squared. So my w would be my x, and my v would be my 7. Since that's a minus, I want to check the value of minus 2 times wv, or minus 2 times vw, however you want to do it. So that's minus 2, v is 7, and x is my w. So that's minus 14x. So that's what I have. So the answer is, I found a candidate for w and a candidate for v, And the minus 2 WV criteria also checks. So my answer is now yes. I do know it's equal to that. So all I have to do now is just replace my W with X and my V with 7. And I now discovered that x squared minus 14x plus 49 is equal to x minus 7 squared. Now let's do 2c. So y squared plus 2y plus 1. Well, our question is, can I find a w and a v such that that's equal to w plus v squared? Well, y squared is y in parentheses squared. And 1 is 1 squared. So if I let w equal y and v equal 1, I have candidates for my v and my w. So since this is a plus here, I just got to check out the value of 2wv, and that's 2y, because v is 1, and that's what I have. So the answer is yes. All of my criteria is met. So my w is y, and my v is 1. So y squared plus 2y plus w is equal to y plus 1 squared. See if you can do this next one on your own. If you've not already done so, I'm giving you the challenge for the next one. Seems like it would be hard, but it's not really. This is 2D. We're given 49x squared. It's almost like I'm live streaming. Plus 70x. God, I hope I did not hit the wrong button. Plus 25. It says stop recording, so I'm not live streaming. So I want to know if I can find a w and a v, since that's a positive, such this is equal to w plus v squared. That's what I'm looking for. So the square root of 49 is 7, and the square root of x squared is x. So the first term would be 7x squared. And 25 squared is 5 squared. So that means my w would be 7x, and my v would be 5. Since that's a plus, we want to check to see the value of 2 times w times v. Well, that's going to be 2. My v term is 5, and my w term is 7x. Well, 2 times 5 is 10. 10 times 7 is 70. And I have 70x up there. So the answer is yes, I have found such factors that allow me to factor this as my w is 7x, and my v is 5. So 49x squared plus 70x plus 25 is equal to 7x plus 5 squared. So let's do 2e. So again, I'm wanting to see if I can find, that's a negative there, a W minus a V, so that this is equal to W minus V squared. Well, the square root of 16 is 4, and the square root of A squared is A. So that would be I can rewrite my first term as a perfect square. I don't do anything with the middle term. And 25 is 5 squared. So that means my W will be my 4A, and my V will be equal to 5. Since that's a negative, I check the value minus 2 WV, which is 2. I'm going to do V first, but not literally V first. It's value. Times W, and that's a minus. Minus 2 times 5 is minus 10. Minus 10 times 4 is minus 40A. And that's what I have. So I found candidates for W and my V. If I can't find candidates for W and V, I'm done. And then I check that the minus 2 WV is what I actually have. So my answer is yes, I have succeeded. This can be factored in the form of W minus V squared, where W is 4A and V is 5. Okay, let's do the last one. Yeah, that's the last one on this page. And after I do the last one, if I can even do the last one, I'm going to do this into 2 parts because the delay is driving me crazy. So I'm going to reboot, and the next page I will do is 13.5 part 2. So this is 2F. I'm given 81 x squared minus 72 x times y plus 16 y squared. So is that equal to a W minus V squared? Can I find a W and a V that'll make it so? Well, the square root of 81 is 9, and the square root of x squared is x. So I can write the first term as 9x squared. Don't do anything with the 72xy, so you can write it down. You can simplify these steps. The square root of 16 is 4, and the square root of y squared is y. So notice if this term were 16 times y instead of 16 times y squared, I'm done, because I wouldn't find a candidate for my V. So my W candidate has been found. It's 9x. And my V candidate has been found. It's 4y. So I can continue on. So since this is a minus, I have to check to see the value of minus 2 WV. So always remember you have to add a minus 2. And I'm just grouping together the 9 and the 4. XY. So minus 2 times 4 is minus 8. And minus 8 times 9 is minus 72. And minus 72 times xy is exactly what I have for my middle term. So my search has succeeded. So now all I do is replace my W with what I found it to be, which is 9x. And my V, I replace it for what I found it to be. Notice W and V in both cases or polynomial terms, variable terms. And I found the factorization to be 9x minus 4y squared. Okay, I'm going to turn this off and reboot the computer, and then I'll start back up with 13.5, problem number 3, where we're looking at a different possible form.